Hey guys, welcome to 2.5 Implicit Differentiation. In this lesson, this is an introduction. So in this lesson, you guys are going to be able to know what the difference is between an implicit and an explicit defined function is. So let's go ahead and talk about explicit functions. Explicit functions are functions defined as a variable in terms of another variable, of an equation of another variable. So for example, the first one, y equals x squared minus 5x plus 7. That's an explicit function because you have y stating that is simply this equation. So it's an explicitly defined equation. F of x equals the square root of x squared plus 5 is also explicit because it explicitly tells you what f of x is. Implicit functions or equations, relations, are actually just equations with x's and y's, not necessarily in any order, but x's and y's just mixed around in an equation. In other words, we don't know what y equals, but that's why it's called implicitly defined, because we don't know what these variables are equal to. Also with the second one, notice that in the middle term we have x times y, and then the last one we also have an x and a y being multiplied functions, and we don't know what y is explicitly. Okay, so this is an introduction video, so I'm not going to go over in depth with the notes on this video. I want to give you guys a brief introduction of what implicit differentiation is before we start moving on with the notes. So let me go over here. So we discussed what an explicit function is, and I'm going to show you guys the difference. So by the end of this video, you guys will be able to know what implicit differentiation is. Explicit. A function that's explicit will look like this. Y is equal to the square root of 9 minus x squared. It's explicit because y is stated to be this. So it pretty much tells you what it is. As far as implicit, for example, if I have y squared plus x squared is equal to 9, that's an implicit because we don't know what y equals. So it's implicitly defined. Okay, so let me take the derivative of the explicit first. If I take the derivative with respect to x, this bottom variable tells you respect to x. What that means is that anytime I take the derivative of a term, and if it's x, for example, if I take the derivative of x squared, it's 2x using the power rule. But if I take the derivative of something else that doesn't have an x involved, for example, if I take the derivative of y, what is y in terms of x? We don't know. So since we don't know what y is, we just can't say the derivative of y is 1 using the power rule. We have to say the derivative of y is dy dx because we're assuming that maybe y is a function of x. So let's take the derivative. Taking the derivative of y, we just said, is just dy dx. Notice you've been doing implicit differentiation already. And then taking the derivative of this, well, that is the same thing as 9 minus x squared to the 1/2. Using power rule and chain rule, drop the 1/2. Take 1 away from the power. And then apply chain rule. What is the derivative of the inside? Negative 2x. And you guys know 2's cancel. So you get negative x, 9 minus x squared to the negative 1/2, which is the same thing as negative x 9 minus x squared to the positive half, since the negative means the reciprocal. And then finally it's square root of 9 minus x, because the power to the half means it's just a square root. So my derivative of this explicit equation is negative x over square root of 9 minus x squared. But what about the implicitly defined function? Now, you could solve for y and get y squared is equal to x squared, negative x squared plus 9, which is the same thing as y squared is equal to 9 minus x squared, which is also the same thing as the square root of 9 minus x squared. Okay, you could do that and take the derivative and you get all the way what we just got down there. So by now you probably figured that these two equations are the same equation, except one's implicit, one's explicit. So how do you take the derivative of an implicit? The same way you take the derivative of an explicit. Take the derivative of each term. What is the derivative of y squared? Well, using the power rule, it's 2, take away 1, it's 2y. But we have to use chain rule here, because we just can't say the derivative of y is just, y squared is just 2y. We don't even know what y is in terms of x, so we have to apply chain rule. Multiply by the derivative of y, which is just dy dx. We have to do this because we don't know if y is changing with respect to x, so we don't know if y is a factor of the derivative. I'm sorry, we don't know if dy dx is a factor of y. So that's the derivative of y squared. What is the derivative of x squared with respect to x? Well, it's 2x, but I don't have to do dx over dx, because if I take the derivative of dx, I'm sorry, if I have dx over dx, that just goes away as 1. This is what I mean. If you take the derivative of a variable with respect to another variable and they're the same variables, you just simply take the derivative. What's the derivative of 9? 0. Let's solve for dy dx. So we're going to move 2x to this side as a negative. Okay, now since I want to solve for dy dx, I don't want 2y in the front, I want to divide 2y. And I see that I get the 2y's cancel. I could even get the 2's to cancel. And I have dy over dx is negative x over y, and that is my derivative. So then you're probably asking, well, sir, this derivative and that derivative doesn't match. Well, sure it does. We already established that y is the same thing as this, because I told you guys in the beginning, well, not way in the beginning, but we had already established that this equation is the same thing as this other equation. So making a substitution, the square root of 9 minus x squared, well, it's negative x over the square root of 9 minus x squared. So what is the difference between explicit and implicit differentiation? Nothing. There's no difference between the two. The only thing you have to worry about is that if you're taking the derivative with respect to x of another variable, for example z plus 1, we don't know what z is compared to x. We don't know if z is a function of x or not. So when you take the derivative of a variable, you always have to rename it as dz dx, or the d variable dx. Now what if that variable has a different power? Well, then the derivative of z squared is 2z, the chain rule, dz over dx. So that's it for the introduction. Now I'm going to show you guys the actual lesson.